Okay, this is what the momentum thickness, that is theta, and here one profile, here it is plate. Okay, so this momentum thickness, it is represent what? Theta. Now see here, the momentum of fluid per second equal to mass into velocity. So mass per second, this is the parameter, and this velocity we are considering this u. Now here, if we simplify, so what will come? Rho b u square into dy. This is equation number 1. Okay. Now next we'll calculate the moment of fluid if the no plate is placed. So no plate is placed. So that time we'll consider small u equal to v. V equal to u. Then, so what will come? The rho u b dy into u. Okay. The loss of moment per second through strip. So loss, here I will erase. The loss of moment per second through strip. So what is that? Rho ub into dy into u minus rho u square into b into dy. This is your loss of moment per second. So now see, total loss of moment, what will come? This is what total loss. So ultimately rho b u minus u into dy. This is your what? The total loss of momentum. So total loss of momentum is what? You just 0 to del. So this parameter represent what? This is third equation. This is your what? The total loss of momentum per second through this point. For example, here it is A, here it is B. A to B. This is your total loss of momentum. Okay? Now, next, let theta be the distance by which plate is placed when the fluid is flowing with a constant velocity. The loss of momentum per second at a distance theta with velocity u. So what is that equation? So loss of momentum per second, that is represent what? We'll see. Now the loss of momentum per second at a distance theta with velocity u. So now see here, what is that? The mass of flow through theta, so rho theta into b into u. This is what? The mass of flow through theta into velocity into u. So it means u square. This is your fourth equation. So equating this equation 3 and 4, so what we will get? We'll equate this equation. Yes, rho theta b du square equal to integration 0 to del rho then bu okay. Now this will cancel, this will cancel, this will cancel, this will cancel. Okay, so what we require? Theta equal to, yes, the integration 0 to del, so u minus small u divided by u square into dy equal to again 0 to infinity, yes, u divided by u 1 minus small u divided by u into dy. So now see, this is our momentum thickness. We'll prove that. Okay. Now next is energy thickness. What is meant by energy thickness? So before that, one shape factor is there that is related to displacement. So I will tell you what is meant by shape factor. The ratio of displacement thickness of momentum thickness is called as shape factor. Again I repeat, the ratio of displacement thickness of momentum thickness is called as the shape factor. So what is it is denoted as H equal to, this is what? The shape factor. Okay, it is the ratio of this and this. Okay, then we'll see the energy thickness. And it is denoted as del suffix E. So one standard formula is there. First I will write that formula and then we'll prove. Del E equal to integration 0 to infinity small u divided by capital U, again bracket 1 minus small u square divided by capital U square bracket complete into dy. This is what? The kinetic thickness. Now we will prove. Okay, Same procedure is there. With the help of that, we are able to find out, or we are proved. So here it is the distance perpendicular to solid boundary by which the boundary should be displaced to compensate for the reduction in kinetic energy of the flowing fluid in a formation of boundary layer. So what is kinetic energy? First you tell me. Ke 1/2 mv square, isn't it? This kinetic energy or this formula we are using. Now m means what? Yes, mass. So kinetic energy of fluid, if the plate is placed, so what are the parameter will come? We will see. 1/2. What is that mass? Yes, rho u into b into dy. Yes, this is what? Mass. And what about v square? So if we are providing or we are placed plate, so that time that is u square. Then the kinetic energy of fluid, if no plate is placed, here it is placed and here it is, we are not placed plate, what will come? Yes, this is as it is, rho u b dy, and here it is capital U square, because we are not providing any plate, isn't it? Now the loss of kinetic energy. So loss of kinetic energy, what will come? Loss of kinetic energy 1/2, yes, rho u b u square minus small u square into dy. So this is your total loss of kinetic energy. Now we will find the total loss of kinetic energy in AB, that previous diagram AB. So what will come here? Total loss of kinetic energy, it will come, yes, here integration part will come 0 to del. Okay. Now the loss of kinetic energy through del suffix E, energy thickness of the fluid flowing with a velocity u or free stream velocity. So what is that? So 1/2 into, yes, density B U now see here the distance, area, del suffix E into capital U. This is what? Mass. If we are considering this parameter, del represent what? Energy thickness, into velocity square. So here u cube will come, and that is this is one equation. This is third equation, and this is fourth equation. Now, after equating 3 and 4, what we will get? We'll see. So 1/2 rho b del suffix e into u cube equal to integration, not integration, that parameter 1 divided by 2 rho b, then integration 0 to delta u square minus u square into dy. Yes sir. Okay. So now here this cancel. Okay. So I want kinetic energy. So energy thickness equal to integration so this is the energy thickness of the, whenever we are considering the boundary layer J or boundary layer. Now you understand?